Welcome to Bubonicon 2020. And for this panel, we are discussing artificial intelligence. Will computers take over the world? Today's moderator is Courtney Willis.
Okay, well, welcome to our artificial intelligence panel. There's four of us here, and I thought one of the ways we would get started is to kind of have some people introduce themselves. So David, would you like to introduce yourself? Tell us something about you and why you might be on this panel.
Okay, my name is David Lee Summers, and great to be here and to see you all on the panel virtually. By day, I write science fiction, fantasy, horror. I have 12 novels. During our COVID-19 pandemic, I've been spending a lot of time kind of revising and getting some new editions of novels out. A couple of the recent ones have been Dragon's Fall, Rise of the Scarlet Order Vampires, with some lovely art by Chaz Kemp, who was to be our guest of honor and I guess will be in 2021. And the new edition, the 25th anniversary edition of my very first science fiction novel, The Pirates of Sufiro, is now out. So with quite a bit of new material in that, and in addition to writing, the reason why I'm really on this panel is that by night I operate telescopes at Kitt Peak National Observatory, and among the what I operate there is I'm been heavily involved in the DESI project at Kitt Peak, which is essentially 5,000 robotic fibers that feed spectrographs on a robotic telescope. That basically the idea is to go through and map the entire sky spectroscopically. And of course, this whole thing basically knows its targets. It goes there, picks up guide stars automatically, starts exposures, and most of us sitting in the room are there monitoring it to make sure it's doing its job correctly. So that's sort of a lot of my background in this. Also, I have a daughter who's been involved in doing some machine learning exercises in her college experience, teaching her laptop to identify exoplanets around other stars. Okay.
Okay. Well, Cathy, you're also an astronomer. How did they twist your arm to get you on the panel here?
Well, so my name is Dr. Cathy Plesko. I am a computational geophysicist. I study rocks in space instead of stars. And my first experience with AI was when I was in my senior year of high school. I was on a glide path out the door for my senior year in the spring, and I got a little bit bored, and the internet was a new thing then. So I downloaded a chatbot and named it Jeffrey and fed it the works of Chaucer on from the Project Gutenberg, which was getting online and accumulating things. So I got to explore how AI at that time was starting to play with natural language processing, which was not well, but it was fun. And then I went off to college and ended up doing my thesis in part applying some machine learning techniques, which is the sort of technical term for artificial intelligence these days, to looking at making geologic maps of Mars, because I had gotten a job counting craters by hand for a professor and decided that that was really boring. But a friend of mine had this new thing called genetic programming, which he was using to look at different photos and try and recognize the objects in it. And that's something that everybody's cell phone can do pretty much nowadays, but at the time was bleeding edge technology. And so I, much to the dismay of my advisor, wandered off from counting the craters that he needed for his crater census and tried to write, or at least co-evolve, a new algorithm to count them for me, which unfortunately turned out to be a lot harder than we thought it would be, because unlike David's amazing spectroscopic project to get all of the different colors of the different stars, the different wavelengths of light that they shine on us, we only had black and white images of Mars at the time. And it turns out that that's very sparse data. If all you can see is shape and shadow, it's a lot harder to tell what something is. And so at the time, we were not able to develop a successful crater counter. And in fact, that problem is still open.
Well, thank you very much. Ian, you're not an astronomer.
I am not. My background is in astrophysics. I did my doctorate studying radio galaxies, but I don't do that anymore. Unlike Kat, in my day job, so I'm phase shifted from David because I do my science in the daytime because I'm not an astronomer, and I do my science fiction writing at night. I guess I sort of fit in this grid here because I work with Cathy at Los Alamos National Laboratory during the day, but I'm not a researcher in AI or robotics at Los Alamos. Sheerly coincidentally, I am the co-author on a paper that we just submitted for peer review, where we tried to train a neural net to do some physics predictions for us. I was not the neural net person in that project. I provided the training data set. So we'll see if that passes peer review. I think my connection to this panel is more through my science fiction life, because I'm the author of 7 novels, most recently a trilogy of fantasy alternate history novels that posit that the Netherlands took over the world after inventing basically an army of clockpunk terminators, sort of sentient clockpunk robots, powered by magic, because magic is a very convenient rug for hiding inconvenient details. But that trilogy, when the trilogy begins, they're all enslaved, even though they have free will. Sorry, they don't have free will. And the trilogy is about them acquiring free will and sort of rebelling. And so through that, weirdly, I've had conversations with real experts in AI and ethics and moral philosophy, because I guess I'm a convincing liar. And some of these people read these books and think that I actually know anything at all about robotics or AI or moral philosophy. But in fact, I don't know anything about that. So good luck making me useful, Courtney.
Well, my name's Courtney Willis, and I guess I round out the panel because none of us are experts in the field of artificial intelligence. So I think we've all bumped into it in one way or another, but I don't think we're actually developing it. So I think we're going to have to talk some about it and some of the ways that we actually get involved and actually have come across artificial intelligence. You know, David, when you, and one other thing, I do have a connection to astronomy, so I guess that rounds us all out a little bit here. I didn't know you had the connection there, Ian, but I started teaching astronomy in 1968 and in high schools. And so I taught some astronomy, but 68, that's a long time ago. So
not much
a few
has changed
things
since then,
happened.
right? Yeah.
Yeah, well, a couple of things might have changed since then. But I think one of the ways that people often come quickly into artificial intelligence, like you mentioned, David, was through games. And you mentioned, you had sent me a little thing, Ian, about that also. It looks like games have made a big change in artificial intelligence in recent years, from chess and Go and Neffen to all sorts of things. Anyone have any comments they'd like to make?
I am what I would call a very, very amateur coffeehouse chess player. And by that I mean extremely mediocre. So I don't know anything about real competitive chess, but I'm interested in it enough that I've long followed sort of world-class chess. So I remember in the 90s, there was this very famous incident where what my understanding is that sort of world-class chess play had been, if you'll forgive the term, sort of a holy grail of computing for a long time, because it was seen as sort of a high watermark of human cognition. So in the 90s, IBM built the supercomputer, which under very controlled conditions defeated the then reigning world champion, guy named Garry Kasparov, who is considered one of the greatest chess players of all time. It's disputable, like, how strong that claim is, because that was a specific mainframe built to defeat one specific human being. And the tournament preparation was not like the way you would prepare for a real world-class tournament. But anyway, they did it and declared victory. That was in the 90s, and now, by the mid-2010s, there is freeware that you can download on your phone. I have it on my iPhone. My outdated iPhone can run a freeware chess engine that is effectively superhuman. Like, if you run it with all the bells and whistles, it's not an open question whether it could beat the world champion running on sufficient hardware. That alone, I think, is pretty amazing. But about 2 years ago, Google unveiled this paper where they showed they had developed this, I think it's some kind of neural net, and they started it out just teaching it the rules of the game. These are how the pieces move. And then they said, go play with yourself and learn how to play chess well. And so it played millions and millions of games against itself, in a very short period of time. And in like 4 hours or 8 hours, it became competitive with Stockfish, which is this engine I was referring to. So it had sort of bootstrapped itself up to very high level, possibly superhuman play in like 8 hours. And so there was a spate of lame jokes about Skynet and stuff when that happened. But it's a very interesting paper. And I guess they had, using similar technology, they had, like 2 years before that, they had developed something that defeated the human Go champion, which people who know Go tell me is even more complicated than chess, which I think is astonishing.
Yeah, I thought there was something, one of the things that was interesting in one of the articles you shared earlier was it talked about the fact that in the 90s you had a computer programmed very carefully with lots of ability to anticipate moves, to plot, very specific as far as how to play chess and how to play chess against this one player. And the philosophy was very much, we have to program in every potential thing that the computer needs to do to counteract possible moves. And I think, what was interesting was the idea that where a lot of the machines are going and where a lot of machine learning has gone is to actually take that back to a lot more of a bare bones approach, make the computer not know so much at first and start feeding it examples, just start letting it actually do, kind of almost like a person learns by doing and running through these algorithms and letting it build up its algorithmic base to know how to defeat other players or other machines.
So the technical term for that is supervised versus unsupervised classifiers. So the classifier is the AI, and it's making decisions. So the original idea was it was looking through photos to classify something as a car, a bird, a cat, etc. For this, it's trying to figure out how to play a game, but still it's supervised is the one where they're very carefully telling it the rules of the game and feeding it all of the records of previous chess tournaments, telling it how the human would solve the problem. And the unsupervised attitude is very much, oh, you'll figure it out. Here's just a pile of data. Go mess with it and see what patterns you see in this influx of information. And it's really interesting to see what they'll come up with either way. And there are very much problems and benefits both ways. With supervised classification, if you're trying to replicate human performance in a way that is very much based on like human aesthetics, then supervised classification can be beneficial because then it has a pattern to follow. For example, if it's trying to come up with recipes and it doesn't have a tongue or any sort of chemical sensor or connection back to the human metabolism that would tell it what tastes good, you have to give it a hint. But if it's trying to replicate the laws of physics or the laws of something that's fairly mathematical like chess or Go, you can let it kind of figure it out. So it's interesting to see, and at the same time, you can also introduce biases. So if you have human supervised classification that's being used as today it commonly is in hospitals, guiding medical diagnoses. So the doctor on their iPad will come into your hospital room and they'll be taking notes while you're talking to them, and they're reading through your chart and all of the sensors that are attached to you and feeding that information in, not only to their brain, but also into a medical classification system that will give them a list of potential diagnoses and recommended treatments. Now, that's all based on a huge number of case histories. Those case histories, however, have the biases of previous doctors baked in. And so they're finding now that some of those biases are actually very dangerous. They tend to include things like perceptions of previous white doctors who had the bad assumption that Black people don't feel pain the same way white people do, or that women complain more than they actually feel pain. And so you get those biases that can actually be quite dangerous and lead to underdiagnosis of heart attacks, underdiagnosis or undertreatment of kidney failure, things like that. So supervised classification can have real pluses and minuses, but then if you just let it loose on the data, you can also come up with some things that humans might find less than useful too. And Ian, I think you were emailing us in a discussion before the panel about some of the ones you'd found where they were pathological cases of AI results.
Yeah, there's a researcher named Janelle Shane. I don't know where she's based. I believe she's an engineer and an optics researcher, but she has a really hilarious website called AI Weirdness, where she, I think maybe more as a hobby, but she turned it into a book called You Look Like a Thing and I Love You, because she tried to train one of these AIs to, like, she gave it a training data set of pickup lines like someone might try to use in a bar, and the best it came up with was you look like a thing and I love you, which is something I actually say to my wife now. But she does these really hilarious experiments where she takes like the Sherwin-Williams paint catalog and feeds it like all of the hue saturation values and all the names, and then has it come up with new paint colors. And it comes up with things like sane green, which is actually purple. And she did another one where she had people upload family recipes, like right off their old recipe cards, complete with the stories, right? Like, this was my grandmother's favorite meal and she always cooked it on Easter. So she got this AI that learned that recipes have to have a story and ingredients, and then some text that might have something to do with the ingredients. And I recommend looking them up, because if you need a lift in the middle of the day, they will not fail to make you laugh.
Why don't you repeat that so people have a chance of looking it up?
Her
name and stuff.
Her website is aiweirdness.com. One word, aiweirdness.com. She has a Twitter feed too. I don't recall her Twitter handle offhand, but Janelle Shane, the author of You Look Like a Thing and I Love You.
I'll put a link in the tags to this video.
Oh, super.
Thank you, Word of God. I think one of the things that's really moved artificial intelligence along has not just been the programming, but also obviously the power of the computers. You were talking about your iPhone there, Ian, but your iPhone's much more powerful than an IBM back in 1968 when I was teaching high school. You know, it makes a really big difference. You can buy a Raspberry Pi now that's much more powerful than a supercomputer was in the mid-70s. And these are computers designed for now for kids to play around and learn how to program and stuff like that. So it's really quite amazing. I think the exponential growth of computing power has fueled a lot of the artificial intelligence and stuff. How have you guys come across artificial intelligence in your everyday life?
I think it's self-defense, oddly enough. So since I got my PhD, the amount of scientific data in the world has doubled, as I understand, twice. So all of human knowledge from before the Library of Alexandria up until I got my funny hat, and then it doubled, and then it doubled again. And I'm not that old. So there's a little bit much out there now. And one of the things that's come along with that impressive increase in computing power is also the blossom of sensors. So having talked to other astronomers who were taking data in 1968, a lot of that was still on photographic plates, as I understand. And now we have very, very high fidelity CCD cameras in our pockets. And we have sensors, wearables that we can wear that watch our heartbeat, our motion, things that are watching our house climate control, temperature, sound. My phone can tell a marketing company if I have a Roomba, for example, because it can hear the sound and phone home to say, oh yeah, she's got one of those, try and tell her one of these. And so there's just this huge ubiquity of sensors in the world now. And while we still have some problems where there's still data poor, in a lot of ways, the world has become so ridiculously data rich that there just aren't enough human brains to deal with all of the data anymore. So we really do need something else to think about it.
And I'll just kind of chime in with, just anecdotally, when I was an undergraduate, in the 80s, I was still working with photographic on telescopes, and I think it was around my senior year of college that I came across my first CCD camera, and it was primitive compared to the thing that's in my phone right here. And it was like maybe 200 by 500 pixels, and everyone thought this was great because, you could actually digitize this data and carry it home on a floppy disk or on a reel-to-reel tape instead of having to, take stacks of photographic plates that are fragile and all of that. And I actually did start out working on one of the very first automated telescopes run by Sterling Gate up at Los Alamos back in the day. He started this project circa in 1966. The idea was it was to be an automated supernova search that he put in around Socorro, New Mexico. And the computer that ran that was basically a 64K of memory. Had 4 gigabytes of hard drive space, and when I worked on it, having 4 gigabytes of hard drive space even in the 80s put me as really up at the top. What are you ever going to do with that much memory? And now I'm working on a 4-meter telescope that was actually built around the same era, but has been retrofitted with computers that essentially are, little small slide in the rack computers that can sit there and do all of the calculations about avoiding pointing too close to the moon, you know, don't point too close to the horizon, all of those kinds of very complicated calculations, which really aren't artificial intelligence, but it also sits there and looks at a CCD camera and says, I have a bright spike on that. I've been trained that's a star. I can get on that. And tell us points, it says, I'm finished moving. I can look for stars. I can now start guiding. And that, even that really rudimentary kind of thing, it does in a few seconds. And each time on our early, you know, refrigerator size 64K computer, you know, was like literally a several minute move each time. You know, it's now like happens in seconds with modern telescopes and computers.
Oh yeah, 64K was enormous memory back in the early 70s or something like that. You know, I was kind of impressed with how AI was coming along when Connie and I bought a new car about 4 years ago. And, you know, I was used to automatic pilot going down the road and stuff. But this one's automatic pilot going down the road. But if the car in front of me slows down, my car slows down. Even though I have it set to go 75, it's going 65 because the guy in front of me is going 65. And I was just kind of impressed with some of that. I've also been kind of impressed where it goes wrong. And I'm not sure I'm totally ready for a driverless car yet, but it was kind of interesting there. Ian, did you have something there?
You know where I run into, I don't know if an expert would really call this AI, but where it enters my life on a daily, literally on a daily basis. I was reminded of this just now because Cathy mentioned natural language processing with her Geoffrey Chaucer chatbot, which I'd never heard that story. That's, Cathy, that's awesome. Just like with the predictive text on my phone, because when I'm commuting, I usually am communicating with my wife through text. And I, you know, I understand they have this large corpus of text users, and Apple is listening to what everyone says, and you know, they train it they learn how you talk, and they have a corpus of how many people talk, right? I don't know, maybe, I mean, my only experiences with Apple devices, maybe other companies are better at this, but we get all sorts of, my wife and I have all sorts of bizarre misunderstandings because, you know, I'll text, sorry, I think I'm going to be, and then the predictive autocomplete will say, and I'm not making this up, fired. It decided I'm going to be fired. And this is a conversation that I have with my wife once a week. Sorry, I'm going to be a few minutes late. And it, no matter how many times it witnessed me saying that, it decided the most logical and most like probabilistically likely thing that I was going to say is, sorry, I think I'm going to be fired. What? I don't know. I guess natural language processing must be really, really hard because that seems like a pretty easy prediction, but what do I know?
One of the things, since I've been a teacher all my life, I taught high school for 23 years, and since 91, I've been a college professor. But my daughter sent me something interesting. She has a good friend who has a child that's kind of on the spectrum, and they're coming out with a social robot for kids to help them with their social emotional learning. So it'll sit and talk to the kid, listen to the kid, see his responses, respond to that in a helpful manner. And it's even programmed so that the kid can't get totally dependent on it or anything, because after about 20 minutes, it gets tired and it goes to sleep. But they've programmed a great deal into this, you know, to actually be working with these kids who are actually having emotional problems and difficulty socially interacting with other people and stuff. And so you can meet Moxie, and that's what the robot looks like. So,
and does it does it interact? Like, does it learn from its interactions with the child?
Yes, it learns from them. It doesn't keep information you can tie directly personally to the kid, but it does feed information in and gets other information back on helping it to respond and stuff like that. And I thought, wow, that's a lot different than chatty Cathy when, you know, stuff like that. So I was really impressed. Talking about the natural language processing and kind of getting ready for this, I was really kind of amazed. There's a program called Generative Pre-trained Transformer, GPT, and it came out, you know, a long time ago, a year and a half or something like that, in the first version, and then it came out in a much stronger version as GPT-2, but people were so worried about how powerful it was, they weren't going to release GPT-2. But now, during the pandemic now, they've released GPT-3, and it's orders of magnitude bigger than GPT-2. And they can have it look at, you know, some of your writing. David, they could look at some of your books and see how you write, and then it can do some writing very much in your style or your style at the end, which I thought is interesting. And it's not just language, but they've also done it with pictures. Pixels, you were talking about that, I think, earlier, David. They can give it half of a picture, take a picture, block off the bottom half, and then ask it to fill in what's down there. And it's really quite amazing. One of the things was drops of water falling down. You don't see the interaction with the surface of the water, but you see the drops falling, and maybe kind of in the background, the circle, you know, of the wave expanding out. And it fills in. Now, it's not necessarily exactly what's happening, but it fills in logical things that could be happening. And some of them are quite good, and some of them are, this is strange. It's from OpenAI, and I don't know if GPT-3 is generally available right now, but I know lots of people have been doing stuff with it. And I think it's quite amazing to be able to write in style of David or Ian or Robert Silverberg, whatever. It's kind of an amazing application, I think, of what's happening.
What did GPT stand for again? I missed that.
Generative Pre-trained Transformer. And it was created by a company called OpenAI. Open, capital A, capital I, of course, but no spaces or anything. And you can look it up on the web, and it has some very interesting things. It's kind of scary to think that, wow.
Yeah, it would be a fun thing to play with. I think about.
Yeah, that's what I was thinking.
Yeah, the thing is I've certainly interacted a lot with the kinds of programs that'll look at your look at your text and analyze it and say, you write in the style of F. Scott Fitzgerald, or you write like Harlan Ellison or something like that, and it's based on really just is a pretty straightforward kind of algorithm about, how many syllables are your words and that sort of thing. But, it's certainly the kind of direction that goes in to then take that and then say, okay, let's generate some text based on the ideas, the kinds of things that we know about.
Yeah. Well, like most of these Zoom meetings and stuff, Cathy, it looks like you have a visitor.
I do. Let me see if he'll come say hi. Yep. This is Calvin. He is now mad on me and ready to go, but he did decide to photobomb.
Yeah.
So,
I think that's happened a lot during the pandemic here. People have gotten photobombed in all sorts of situations. So.
Yep, it has. I have been photobombed with a cat perched here on the couch while I've been giving a lecture, and I think it distinctly improves the quality of my science.
Yeah,
so
I think
it is a silver lining. A question for Ian and David. So who do you think in the sort of grand circle of publication will get replaced first, the author or the slush pile reader? Which do you think is a harder problem for AI?
Ooh.
I think that's a great question. I think a lot of the slush you could do with AI. I've never worked as a slush reader, but I know many. They're like the weirdos who don't write their stories in standard manuscript format, but write them in crayon on a shopping bag, right? Which is a surprisingly large fraction of the slush pile, from what I understand. You could do that automatically. And then probably the next person to get replaced would be me. And then, good writers after that.
Oh.
But no, I think, it's, just as the fact that, I think, there's sort of a maxim out there, everyone's a writer. So I think there's probably more of a need for slush pile. There's probably more of a need for slush pile readers. So that would be the direction I would certainly hope would come first. And as having read slush piles before, I think, you not only get the that first layer that's exactly, it's full of misspellings, I recognize that right away. The AI has learned that, people who write in the style of, could sit there and say, well, this looks an awful lot like, this is pretty much, someone who's read way too much Isaac Asimov, write like Isaac Asimov or whatever, which, may not be bad until you're writing Foundation all over again, and then they chuck you aside. So, recognition of some of these kinds of things could be, I think, could certainly be done.
Just from what I've known over time and stuff, and what I was reading about GPT-3, it looks like, say, an editor could put in 3 or 4 stories that they like, and 3 or 4 stories that were in the slush pile and got dumped, and GPT-3 could go through some of this and do the slush pile reading. Save a few people's gray cells up here a little bit, from what I understand on some of the slush pile. So I don't know for certain. One thing that we haven't talked about.
Sorry.
I'm sorry.
Oh, I said that would actually be a very interesting experiment to try.
Yeah. One thing we haven't talked about, and I think is important, I think we've been going for about 40 minutes, and the one thing we have to talk about if we're talking about AI is the difference between, I guess, machine learning, which most of this stuff we've talked about, the computers that learn how to play chess basically on their own and stuff like that, and HAL. In 2001: A Space Odyssey. And the difference, of course, is HAL's a sentient, I don't know if I can call him a being, person, a sentient computer program, whatever. But Huh?
Self-aware, I guess you could say.
Yeah, he's self-aware and stuff. And I think that's really important because doesn't that actually come up a lot in science fiction, where we have self-aware computers and not just, you know, pre-programmed robots?
Right, and I think one of the things that's up when you start reading about AI is that there is AI people tend to classify these things as weak AI versus strong AI, and weak AI is a lot of what we've been talking about, which is artificial intelligence that is trained by a lot of examples and learns to recognize things by example, maybe even learns to replicate some things by example, learns how to play games because it can mathematically analyze things very quickly. In the case of recognizing planets around stars, it's looking at patterns in the levels of brightness of that particular star. So again, it's pattern matching and learning to recognize those kinds of things. Strong AI is kind of where you take that and actually make the next logical, actually make leaps of logic beyond that and actually start asking, can the machine, is the machine actually capable of making more distant leaps? And one of the things that struck me when we were talking about chess matches is, okay, a computer might get very good at being able to play a game of chess, but is the AI going to come along and say, well, I don't really feel like playing a game of chess. I feel like writing that book instead. I do. And so far, I don't think we have any. Yeah.
10 minutes.
I don't think we have an AI that does that.
Yeah. One of the interesting things seems to be whenever we have new technology, some of the first things that people do with the new technology is either commit a crime or apply it to pornography. Any suggestions on what our future on AI might be? What kind of crimes you're going to plan? What kind of crimes you're going to have in your books?
I think a writer who gives a lot of thought sort of in that, or there are many, but the first one who springs to mind for me is Charlie Strauss. And I don't remember which book of his it is. It's probably in several. It might be a book called Accelerando by Charlie Strauss, where, there's we're familiar with the concept of like shell companies that people use to hide wealth. And there's this bit, I think it's in Accelerando, where this guy has this AI that is constantly filing paperwork to create new organizations and new shell companies, and then spinning off companies from those companies, and doing it, at a computational speed to obscure his wealth and other holdings. And then it's like this arms race, because then there are like financial investigators who have their own AIs that are simultaneously like backtracking this tree in real time. And I kind of love that idea because I think it's frighteningly plausible. Just looking at the arms race between email spam in the 90s and spam filters in the 90s, which I thought was going to be where, that might have been the spark that created a strong AI. But yeah, Charlie Strauss is very good at that sort of thing.
Okay, well, I according to my timekeeping, we've been going about 45 minutes or so. Why don't we do this? Why don't I ask each of you to think for a moment about any final statements you'd like to make here, okay? And then I will kind of arbitrarily pick on you and have you come up with something. I'm trying to talk a little bit here to give you guys a bit of time to think here while we're at this. Ian, final statement.
Can I cheat and ask Cathy a question?
Sure.
Uh-oh.
No, I'm not trying to put you on the spot. I got really interested. You were talking about the difference between supervised and unsupervised learning earlier in the panel when we were talking about chess, which is ultimately unimportant. The Google thing with the unsupervised learning, I guess, where it sort of taught itself. An interesting thing that a lot of chess players picked up on was, unlike the decades of work in chess where you could sort of unravel what Stockfish is thinking because it's rule-based, it has these evaluations. With Alpha Zero, nobody really knows what it's thinking. You can look at what the layers are doing, but it's not identifiable as, oh, it's concerned about this piece on the board, or it's concerned about this strategy. So in more important applications, like you were talking about medical applications, is that a concern, or would the idea be?
That is a concern. So
Okay.
there's supervised and unsupervised classification, and there's also, I'm forgetting the proper technical term for it, but there are black box AIs like neural nets, where you don't know how it's making the decision. You can sort of see what different layers are doing, or there's a whole genre of coming up with non-black box AI algorithms where you can see the program and see what it's doing. So back when I was doing my thesis, the classifiers that I was using were supervised because I was giving it marked up images that says these pixels are crater, these pixels are not crater. And then it had a list of different operations to choose from that it could do on the image. And then it would string them together in a program, and I would be able to read that program to say, okay, now it's doing a dilation, now it's doing this kind of kernel filter, now it's looking for this, now it's looking for that. So I could see exactly what it was doing, and this was a support vector machine. So it was something where I could figure out what it was doing, and then I could take several examples of, okay, this attempt did this attempt did that. What are the commonalities? And see what were the most important parts of the program and what was maybe junk DNA. In a neural net, you can't do that. And so there are entire non-black box AI programs that are used to study the black box AIs to try and reverse engineer what they're actually doing in order to make judgments as to whether or not it's okay. But a lot of times you just have to keep watching the training data and what emergent effects does it have? For example, if it's a sentencing guideline being used in a local court system, does it seem to be unduly prejudiced against people of certain ethnicities or against people of certain genders or people who live in certain areas? What is the bias? And you have to sort of guess and figure it out and keep monitoring it. So yeah, this is a constant problem that is not a future tense problem. The future is now for those sorts of issues. And that's something that is a very interesting and very impactful area of study, to my understanding. Because again, still not my field. I'm at the level of I can download scikit-learn and apply it to science I actually understand. But then having done that for a while now, I understand just how much trouble people can get into doing that, which does concern me for the near-term future as we're starting to discover people stumbling onto these sorts of problems when doing high-impact things like medical diagnostics, jurisprudence, or deciding whether or not you get an interview for a job. So does that answer your question?
Yes, it does. That's very, very interesting.
Awesome, thanks.
David, do you have any final comments you'd like to make?
Well, I was actually, even as Cathy was speaking, I was thinking about the strong AIs versus weak AIs, and I think about the two intelligences that I've been charged with raising over the last 20-some years, my two children, and not. And thinking about, what are the things that I've done to train them. And I think, a lot of it has been training them for things like survival And it really makes me think about whether, you know, a lot of the breakthroughs we might get in artificial intelligence might actually come, you know, now that we are talking about creating things like self-driving cars, which are there to figure out how to get us safely from place to place. And then even taking that further, technology goes into things like Martian rovers, which have to be autonomous enough to figure out, you know, where do I go to get enough sunlight to keep my batteries charged, and start, you know, having it answer its own questions about things like survival, in addition to questions of, well, how do I just complete this task that my masters have sent me to do? It makes me wonder, you know, I don't know whether that's like gonna be that unlocks something like strong AI or even sentience, but it does make me wonder if that's gonna start, you know, if breakthroughs that are gonna start leading us to some really interesting things in artificial intelligence, and artificial intelligences that are gonna come to us and, you know, start asking why we're asking it to do that. Thinking about your point, Courtney, about, you know, what we tend to send people to do is crimes and porn. So.
Ian, you basically only asked a question. Do you have any other comments you'd like to make?
Well, you caught me. I think I'll just say extremely briefly that Courtney, you mentioned having experience. You're thinking about self-driving cars because you have this cruise control in your car now that actually monitors the car in front of you. And I think the wariness of self-driving cars it's not a bad idea to be wary, right? Because there are a lot of super complicated ethical questions that the people programming these cars have to solve in a way that's societally acceptable, right? It gets into things like the trolley problem, and is it acceptable to deliberately kill one person to save 4 people, all that. So I don't think it's going to be unraveled anytime soon.
Well, I think we're just about done here. I'd like to thank all of you for being on the panel, and I'd like to thank Bubonicon for having us. I think we could have gone on a whole lot longer here because I have several other things in my notes, but I don't think we have much more time. So, word of God, I think we're about done.
Excellent. Thank you, everyone. Thank you for participating in virtual Bubonicon, and hopefully we'll get to see you guys in person next year, all things considered. So
we'll keep our fingers crossed.